Hello everyone, in this presentation we are going to understand how to interface a dip switch and LED with LPC2148 microcontroller in VA Microsystem Development Kit. Here we can see this is the LPC2148 microcontroller and this is the dip switch and this is the corresponding LEDs which are connected as shown. So the program has been written and we are able to see how the dip switch is used to switch on and switch off the LEDs. So now all the 8 dip switches are off. Now all the 8 ditches are off. So all the LEDs are off. Now I am switching on the first LED. Switching on the first switch, first LED is on. Second switch is on, second LED is glowing. Third switch is on, third LED is glowing. Fourth switch is on, fourth LED is glowing. Similarly, when you switch on all the switches, the corresponding LEDs are glowing. So when I switch on, now all the 8 switches are on, so 8 LEDs are glowing. Now I am switching off the individual LEDs through dip switches, switching off the second LED, switching off the third LED, switching off the fourth LED, switching off the fifth LED, switching off the sixth LED, switching off the seventh LED, and switching off the 8th LED. Okay, so with the help of 8 dip switches, 8 different LEDs are switched on and switched off. Like this we can able to implement several applications. By doing this experiment, what we have understood here is I can able to give the input to the LPC2148 microcontroller and I can able to bring out the 8-bit data from the microcontroller. That is what we have learned. The code for implementing this is shown here. Here if you see, so the LEDs are connected to the port pin 1.24 to 1.31 and the dip switches are connected to P0.16 to P0.33 as we see 0.16 to 0.23 as we see here, and as usual we are starting the code by hash include lpc2148.h and we are initializing with a variable called a and that is a delay routine. So before proceeding further, we should know where the LEDs are connected and where the dip switches are connected. So for that it is mandatory for us to look at the circuit diagram of this circuit diagram. If you observe carefully, so the LEDs are connected to P1.24 to 1.31 and the dip switches are connected to P0.16 to P0.22. so getting the data from 0.16 to 0.23 and sending out the data to P1.24 to 1.31 is the objective of this particular coding that what we are supposed to do. So that is why in this code, when you look at the initialization, pin cell 2 is initialized to 0 to make all the GPIO lines of port 0 as GPIO lines. So IO1 direction register is made as FF followed by 6 zeros to make the higher order 8 bits of port 1 to be an output port, and IO0 direction register is made as all zeros to make it as input port, where the dip switches are connected to port 0 and LEDs are connected to port 1 higher order 8 bits. That's why higher order 8 bits of ports 1 are FF to configure it as an output port. So these are all the initialization of port 1 as output port and port 0 as an input port for getting the input from the dip switch as well as giving out the data to the LED. So inside the while one, here you can see the pin status of port 0 is taken to the variable A. That means the entire data, 32-bit data of port 0 will be taken to port A because all the 32 bits are configured as input port. All the 32 bits are configured as input port. And then we are left shifting to 8 times. Why we are left shifting to 8 locations if you observe carefully? So the LEDs are connected to higher order 8 bits, but the switches are connected to P0.16 to 0.23. So after reading the value from the port 0, doing 8 left shift will make us to send out the data directly to the port 1 as we see here. So with this understanding, the coding is being done, and after 8 left shifts, the A variable content is moved to port 1 of LPC2148 microcontroller. When we simulate it, we can understand little bit better. After compiling and building, we are going for debug start-stop session. After stopping the debug session, here we are able to see port 0 is an input port and port 1 is an output port. So when I run this code, when I do the single step, now the program counter is pointing 12th line. So when I do the single step, all the port 1s are GPIO port pins. IO1 direction registers are made as FF. Higher order bytes are made as FF. As you see here, when I execute it, it will become FF. Yes, you can see FF followed by 24 zeros. Then when we execute the 14th line, all the port 0 pins are configured as input port. Yes, all the port 0 pins are configured as input port. Now inside the while one, port 0 content are moved to the variable A, and A content is left shifted 8 times and given to port 1. So port 0 content of 0.16 to 0.23 are all are 1. It is taken in and it does 8 left shift and bringing out through this 24 to 31st pin of port 0. So now if you see, now I am changing the inputs, right? This is the dip switch, right? Look at the screen, look at the cursor. This is the dip switch. So when I change some dip switch value from 1 to 0 and I run this code, you can able to see in P1.24 it changes to 0. When I make this bit as 0, in P.125 it becomes 0. So 0 means third bit has become 0, 0 means fourth bit has become 0, fifth bit has become 0, sixth bit has become 0, seventh bit has become 0, 8th bit has become 0. When we make it as 1, 1, 1, 1, 1, 1, 1, 1, 1. So the reading from the port 1 is taken into the variable A and then it is left shifted 8 times given to port 1. With this simulation we can understand how to read the 8-bit data in the 32-bit port and how to do the left shift and how to give out the 8-bit data in the 16-bit port of ARM7 LPC2148 microcontroller. After simulating this, we have to download this code into the microcontroller kit. For downloading the data into the microcontroller kit, we need a flash magic tool. So this is the flash magic tool. Through this flash magic tool, we are supposed to download it. Now I am just downloading this code by clicking the start button. You can able to see it is erasing the previous code and is programming the new code. It is verifying and the programming is being done. And then if you look at this kit, now the kit is having it downloaded. So after downloading, I'm coming to the execution mode and then I'm switching on the corresponding dip switches as per the requirement. So all the 8 LEDs are glowing. Now I am switching off. All the 8 LEDs are switched off based on my switching conditions. So this experiment justifies I can able to interface dip switch with microcontroller, and I can able to interface LED with microcontroller, and I can able to access the dip switch value, and the status of the dip switch value can be monitored very clearly in the LEDs through LPC2148 microcontroller development kit from VA Microsystems. Thank you very much.